For my distance learners, I should have just added this at the end of the last video, but it didn't occur to me until I already ended the recording. So I'll try to be more mindful of that in the future. We're looking at number 1. So did this example seem extremely similar to the notes example? Hopefully you're thinking yes. Instead of having only 200 students, now we have 2,000 students, of which 230 are left-handed. We're going to take the same size sample, 50. Which of the following could describe the distribution of the sample mean? So what they are referring to is this. A random sample of 50 was taken. What would the sample mean look like? Well, we would expect it to look very similar to the population. So the population has a percent of left-handed kids. That's 230 divided by 2,000. So about 12%, 11.5%. So now let's go down and see what our options are. A bar graph showing 230 left-handed and 1770 right. No, that's the population. That would be your population distribution. A bar graph of 9 left-handed students and 41 right-handed. Well, I don't know. How many is 9? So I'm going to type in 9 divided by 50, and that's 18. Okay, I think it might be that one. Is it reasonable that it would be so high up? It's unlikely, but we could get one. So I'm thinking right now it is B. A normal curve with a mean of 11.5. No, that's the sampling distribution. A normal curve with a mean of 9 over 41? Nope. A distribution that is skewed right? No. So the only option is this bar graph, because in our sample distribution, they were all bar graphs. Is it okay that they're frequency instead of relative frequency? Yes. Are you okay on that one now? Okay. The next one, I think, is one of the most challenging questions from this whole unit. Which of the following has a mean that varies? 1, the population distribution. Well, no. The population distribution has a P of 12. That's the only value it can be because it's the true value. So this population distribution never changes. It's always P is 12. The distribution of sample data. Well, here we got a 10. Here we got a 14. Here we got a 12. So is the distribution of our samples varying? Yes. And then 3, the sampling distribution of the sampling mean? No. This is your sampling distribution, and its center is 12%. It is the same as your population. So this one is 2 only. And this page in your notes and page 502 are all trying to get you, both of them are trying to get you to understand this question too. Which have a mean that varies? Only the samples vary. The population and the sampling distribution usually match. Are you okay there? Okay. So that leads us into our next idea, and that is the idea of the sampling distribution and the population distribution matching. So our last topic for the day is this idea. Well, it's 2 separate ones. One is variability, and the other one is bias. So some of this should sound familiar. So these are my protesters. I've used this example for a while, before a lot of people were protesting. But so we want in any sample distribution or sample, we want there to be low variability and we want there to be low bias or no bias. So let's start with variability because that's the one that I bet you we feel pretty good about. So the spread, which is the same thing as variability, so I'm going to write both. The spread / variability of the sampling distribution. Is that true? No. The blank of the sampling distribution is determined by the sampling design and the size of the sample. Okay, so back on this page, when we ended with this sampling distribution being normal, a normal curve that has a center at the true value, we want this to have low variability. We want all of our samples to be clustered around the true value. So how do we get this to have the lowest variability possible? How do we take this normal curve and squeeze it together so that most of the values are around the true value? Well, there's two ways. Number one, you have to have a good sampling design, meaning the way you choose your sample is important. It has to be a random sample. So the biggest takeaway right now from this one is that the design has to be random. If you go through the problems, you should see it clearly stated in the prompt that whatever sample they took is some kind of random sample. You guys will also see it as an SRS. What that is a simple random sample, a simple random sample. So you're looking for, we took a random sample or we took an SRS. The other one is the larger your sample size is, the lower your variability is, and here's why. If your sample is larger, it includes more individuals, and the more information you take, the closer you get to the truth. Does this make a little bit of sense? So if I ask you guys, well, if I ask two of you, how do you feel about distance learning Fridays? One of you guys might say hate it, and the other one would say love it. Or both of you might love it, or both of you might hate it. Are those two kids going to accurately reflect thousands of kids? No. But if I took 1,000 kids, is that going to give me a better idea about how you guys feel about distance learning Fridays? Yes. So a bigger sample size means more information about the population. More information is always better. So larger samples give smaller spread. What they mean by that is the larger your sample is, the tighter or more squished together this normal curve will be, which we want. We want this to be as close to the true value as possible. If the population is much larger than the sample, at least 10 times as large, the spread of the sampling distribution is approximately the same for any population size. So what they're saying is, if we have, let's say we have a population that is 8,000 individuals. If we take a sample size that is 800 or bigger, so once you get 800 people in your sample, that's the lowest, essentially the lowest your variability will be. Once you hit about 10%, at least 10% of the population as your sample, your spread is approximately the same for each sample size. Does that make a little bit of sense? So 800 and above, or 10% and above, and the distribution, the variability will be the same. Population size is not important. The only thing that is important is your sample size. So it doesn't matter if your population is 8,000 or 80. In that case, if it were 80, as long as you sample 8 people, the variability will be the same for 8 and higher. So first thing is variability. We want to think of that normal curve, and we want to remember we want that normal curve to be centered around the true value as closely as possible. How we get that is a large sample size, and your sample has to be random. Now, for bias, this guy is a little bit more complicated. But before I get into it, the only way that you can reduce bias is by your sampling method. The only way that you can affect the bias of a sample is to take a random sample. So you're going to get a question that's going to try to trip you up on that. Sampling, random sampling, is the only thing that affects bias. Sample size affects variability. So sample size does not matter here, only randomness. So a statistic is unbiased if the, I believe that's the word sample. Don't write it in yet though. Nope. If the mean, remember this is the same as average. If the mean of its sampling distribution is equal to the parameter of the population. Okay. So what we're saying is mu, okay, here we go. Let's look at our test. Let's go back to our test data, the longer one. So it's on the back of this, is that true? No, it's on the back of this, no. It's page 503. I don't know where my page 503 is. Right here. Okay, this is what we're looking at. Are you ready? Okay, so for this problem, our population parameter was 78. That's true mu. So is this sampling distribution, or is the distribution of our samples, an unbiased estimator? What we need to identify is what is our average sample average. That sounds weird, right? So here's what we got to do. We got to enter in these values into our calculator and find the average of these values. Is that making a little bit of sense? So let's go. Let's see who gets done first. I bet you it's going to be me because I'm so fast. If I can find my calculator before you. So I'm literally going to go into one of my lists. I'm going to clear it out. And I'm going to enter in 60, 60, 60, 60. Or you can add them all up. I feel like that'd be harder. 64. Oops. Okay, I got a value. One of you guys let me know when you get a value. Or should we just trust mine? Thoughts, family? Okay, so each one of these dots represents one of our samples that we found. Yes? You're okay with that? And the dot is the average score of the 5 kids that we sampled. Now what we are finding is the average of all of these scores. So here's how you denote that, because it has a special, let me find a color. I'll use pink. It has a special symbol. It is the mean, I'll zoom in. It is the mean of your samples. It is the average value of your samples. So our true average is 78. Our true average test score is 78. What is the average values, or sorry, I should say value. What is the average value of our samples? That is 74.9. And how I found that was, and I'm pretty sure that this is accurate. I put all of these values in my calculator and then used my calculator to find the average value. So I'm going to explain that one more time. This is the true test average, 78. This is one sample of 5 kids who had an average of 95. This is the average of all of our samples. Are you hanging in? So a statistic is unbiased if these two things match. Your true parameter has to match the average value of your sample. So is this biased or unbiased? This is a biased estimate. This is a biased estimate. Your true mu needs to equal the average of your samples. I'm going to write that in. This guy is the average of my samples, or sample values, whichever you prefer. Now, most of the time, you look at the center of your distribution, because if you have a true sampling distribution, it should be uniform. It should look like the nice curve. And in that case, the center of your distribution is the same as your mean. Mean and median equal. It didn't work in this case. This did not work because our samples did not have a normal distribution. Our samples did not have a normal distribution. So our center value is not the same as the true value because this distribution is not normal. If that doesn't make sense yet, I think we'll get there next time. So that's what these last graphics are showing you. You have this distribution. Is this showing, or would these samples give an unbiased estimate? And the answer is no. This top one is biased. Why? Because your true mu or p is here. But where is the average of this distribution going to be? Probably somewhere over here. This line is x, sorry, these have different things. Mu sub x bar or mu sub p hat. So your population parameter is over here. The mean or the average of your sample is probably over here toward the right of this distribution, because this is right skewed. This one, though, is not biased. The second one is not biased. He's roughly normal, which means that the center of the distribution would be the mean value. So this is a case where mu equals mu sub x bar, or p equals mu sub p hat. And we're going to go over these symbols a lot more, so you don't have to have that perfect right now. So this guy is not biased. Just kidding. This one. Yes. This one is unbiased. This top one is biased. What do you guys think about the third one? It is also unbiased. When you have a symmetric distribution, your mean and your median are the same. When you have a symmetric distribution, your mean and median are the same. So if we look at the middle of this data set, it is in the same spot as the actual population parameter. So this is unbiased. And then this guy, definitely biased. This guy is definitely biased because your population parameter is here, but the mean of your sample is here. So this is the mean of samples. This is the true value. So I know that this one is a little bit harder to be clear on. We want to rely on the idea that it's not biased if the average of your samples equals the true value. But then they go and muddy it up by making you guys look at the centers of the distribution. And the reason they're having you do that is because if a distribution is symmetric, the mean and the median are equal, and that makes it easier to tell. Are you guys kind of okay there? So, before I forget, the only thing that affects bias is random sampling. Also, you cannot reduce bias. It's either biased or it's not. You cannot reduce bias. You can reduce variability. Your data, your distribution can be really spread out or really squished in. So you can reduce that. But bias is either a yes or a no. You cannot reduce bias. I'm going to write that in too. Okay. So let's have you guys finish or do. Okay, on the first question, it is W is unbiased and R is biased. So it's the third one down. This one, all they do is increase sample size. So your bias will remain the same and your variance will decrease. You cannot reduce bias. So bias remains the same because you didn't change whether it was a random sample, you just changed the sample size. Does that make a little bit of sense? Okay, last question is on 51. This is why I didn't have you hand it in. Was our gymnastics sample an unbiased estimator? So I shouldn't say sample, I should say example. Was our gymnastics example an unbiased estimator? So that means that I would need to go through and average out these 10 values. And I did. The average of these samples is 20. If you add up these 10 values and divide by 10, you get an average sample of 20. Is that biased or unbiased? Well, our true value is 20. So are we biased or unbiased? Unbiased. If your sample average equals the true value, you have an unbiased sample. Well, why does it not match the center of my distribution? Because here in our notes, we just looked at the center of the distribution. Well, it doesn't match because this distribution is skewed left. So your median is over here and your mean is here because this is skewed left. So you have to look at the average sample value, not just the center of the distribution. Okay? Okay. Leave your 51s at your desk and I'll walk around to come get them. I haven't found your text yet. I'll keep looking. I don't know where it is. Okay. I will post solutions for 52. I'll try to get those up before I leave today.